All right, guys, welcome back to another edition of College Algebra Prerequisite stuff. And so this is section P6, Rational Expressions. You're going to have two videos on section 6. We're going to spend the first half of it multiplying and dividing rational expressions, and then we'll deal with adding and subtracting rational expressions later in the next video. Rational expressions, of course, are just fractions, and not everybody enjoys fractions. But we can use them, and they're very important to be able to handle. And so this video here is going to touch on these first four ideas, looking at the domain of a rational expression, simplifying, multiplying, and dividing. Okay, and the big thing that you've got to know in order to do this, the big thing you've absolutely got to know is you've got to know how to factor. So we just did factoring, all sorts of different ways of factoring. In section P5. So if you have not done that and have not gotten that really good, down really well, then you're going to have trouble in this section. So make sure that you've got P5 down, factoring, before you come into this section. Okay. So a rational expression is just a quotient of two polynomials. It can be other, there are other types of fractions, but technically they're not called rational expressions. And the domain is simply when the bottom equals 0. Those are the things you don't want. You're not allowed to divide by 0, and so a rational expression has a domain of all real numbers except for the numbers that make the denominator 0. Okay, so here's an example. Here's an expression, 7x divided by x squared minus 5x minus 14. And so if you want to find the domain, you simply set the bottom equal to 0. Set the denominator equal to 0, and then in this case, that denominator does factor. And so if we factor it equal to 0, then that tells us that what? X minus 7 could be 0, or x plus 2 could be 0. That's the zero product property. And so if you take a look and you see x minus 7 equals 0, that gives you x equals 7. And if x plus 2 is equal to 0, then that says x is equal to negative 2. Now remember, what does that mean? That means that the domain is everything else, right? I don't want 7 and I don't want negative 2. So I will actually accept you writing it like this, okay? But I think my math level required a little bit more formally, all right? But that's the idea here, is that you want x not equal to 7 and not equal to 2. Everything else is good. If you tell me what it doesn't equal, then that tells me that it equals everything else, okay? So as they write that out, exactly the same thing, right? X not equal to 7, x not equal to negative 2. Okay? So make sure you try a couple of those. To simplify rational expressions, all we need is that we want to have no common factors between the numerator and the denominator. So the steps for doing that is you have to factor the top and the bottom completely, and then you divide away. Right? Remember, we're not going to call it canceling. We're going to call it dividing them away, because when you cancel things, they disappear, and that's not mathematical, right? So we're not going to think of it as canceling. We're going to think of it as dividing like terms, or dividing like factors. And when you divide something by itself, you get a 1. So as an example here, what I'm talking about, not with numbers, but like, let's say we have 8 over 12, right? So 8 is 4 times 2. And 12 is 4 times 3. So what we do is we don't quote unquote cancel. All right, what we do is we break this up and we say, okay, we're going to have 4 divided by 4 and 2 divided by 3. And then what happens to 4 divided by 4? That becomes a 1. All right, and so then that's how you reduce your fraction, and you come up with 2/3 as a reduced fraction for 8 out of 12. That's all we're doing, except we're doing it with algebraic expressions now. And so when you take a look at this algebraic expression, x squared over at minus 1 over x squared plus 2x plus 1, all right, well, what happens? We factor the numerator. The numerator is a difference of squares that factors into x plus 1, x minus 1. The denominator factors into x plus 1, x plus 1. If you do the math here, x plus 1, 1 plus 1 is 2. That's how we get in the middle. And then so now what we're going to do is we're going to say this x plus 1, they don't cancel. Okay, they divide away. And when they divide away, that leaves us with a 1. Okay, that leaves us with a 1 in both of those places. And so When we divide them out, that leaves us a 1 in both of these places. And so we're left with x minus 1 over x plus 1. And of course, x is not allowed to be negative 1 because that's when the bottom would have been 0. Okay, so you have to kind of leave that out also for that. Okay, that's how we simplify our fractions. Multiplying rational expressions, what you want to do in order to multiply so that you don't, and again, this is the same thing. So, right, if we had like 8 over 12 times, we'll say 9 over 5, okay, then you could just multiply across and get 72 over 60 and then try to reduce it, or you could break this down into 4 times 2, this is 4 times 3, this is 3 times 3, this is 5 times 1, and now we can cross cancel here. 3 divides 3 and leaves a 1. We can divide the 4's away and leave a 1. Still multiplied, okay? And so then we multiply across the top and we get 2 times 3 across the top, and we get 1 times 5 across the bottom, and you get 6 over 5. So if you reduce, again, dividing away, we're not canceling, we're dividing away and dividing away common factors, then that allows us to simplify and get our multiplication and division later. That allows us to do it without having to simplify at the end. Okay, so this first step is to, if you want to multiply these two rational expressions, you want to factor the polynomials. X squared minus x minus 6, that factors into x minus 3x plus 2. X squared minus 4, difference of squares, factors into x plus 2x minus 2. X squared plus 6x plus 9, that's actually a perfect square trinomial that factors into x plus 3x plus 3. And so now you start to look for things that are in common. The x plus 3's are in common. The x plus 2's in common here. Okay, and so we're going to divide those away. Divide the x plus 3's, divide the x plus 2's. All right, and then of course you have to make sure you know what you're not allowed to have. You're not allowed to have negative 2 or positive 2 or negative 3 because that's when the bottom is equal to 0. Okay, so you can see once again factoring. If factoring is not something that you're strong with, right, this section is going to be really, really challenging. And so you got to make sure you can factor before you try to do this stuff. All right, so if we come over to the next page, we'll see here we divide it away. Remember, this leaves a 1. They don't cancel. These leave 1s everywhere. And so there's a 1 up top here. These guys are still a fraction. And so we get 1 times x minus 3 times 1. That's just x minus 3. All right, you get the x minus 2 and the x plus 3 on the bottom. And so those 1s, you don't need those, okay? And then obviously x is not allowed to be what? It's not allowed to be negative 2 from here. It's still not allowed to be negative 2. All right, and you're not allowed to be 2 or negative 3 for that matter, but those are still true. But you have to write this out and let me know, hey, negative 2 used to be a problem, now it's not a problem anymore. You need to notate that, okay? If you want to, and so we've got all 3 of these listed. They went ahead and listed them all out. But don't multiply this out. Nope, I disagree with that. This is the final answer. This is perfectly fine. There's no reason to multiply these out again. And then letting me know what you're not allowed to have. Okay? But you do not have to multiply it out further. All right, if you want to divide rational expressions, you just have to remember that when you're dividing, if you have a plus b divided by c over d, a over b, let's try that again. If you have a over b divided by c over d, right, then that's the same as a over b times d over c. You keep, change, flip is what a lot of teachers will teach. All right, keep the first one exactly the same, change from division to multiplication, and then flip the second one. And the reason we do that is because the inverse of division is multiplication. That's one inverse. And so then we flip this over. The reciprocal is another inverse. Both of those are multiplicative inverses. And so 2 inverses kind of cancel each other out, basically. And then you multiply across the top and the bottom. You do it the same way we just did. Okay, so you factor. You want to flip it over. first things first is flip it over. Division becomes multiplication, and you flip the second term, the second fraction. All right. Then we factor as much as we can. Okay, I'm going to go to the next page so you can see it clear. Okay. Well, maybe not. All right, so we factor here. This numerator factors into x minus 1, x minus 1. Here we have a common factor of x we factor out. Okay. Here we factor out a common 3. And then x squared plus x minus 2, that factors into x plus 2, x minus 1. Okay, so here's your factored form. Okay, sorry about that watermark there. Can't get rid of that right now. And so, of course, if the denominator was equal to 0, this guy's never equal to 0, but you get x equals 0, x plus 2 equals 0, and x minus 1 equals 0. Those are the numbers you need to leave out. And then when you go for common factors, x minus 1 cancels with x minus 1, and a whole x squared plus 1 cancels with x squared plus 1. That's totally fine. Those leave 1s, and so you're left with 3 times x minus 1 and x times x plus 2. You can see that there. Okay, and again, I am not a fan of this. No, don't want that at all. I just want you to write this as 3 times x minus 1 all over x times x plus 2. Just leave it like that, and then you're going to leave out 0, negative 1, and negative 2. We're going to leave those out. Okay, so that's the process for simplifying rational expressions, for looking for the domain, and also for multiplying and dividing. In the next video, we'll tell you, talking about how to add and subtract rational expressions, and also how to deal with complex fractions, which is basically fractions inside of fractions. Okay, we'll see you then.